Let's go ahead and continue practicing reducing square roots, only this time we're going to throw some variables in there because we can also reduce variables under our square root sign. So we want to assume that all variables represent non-negative numbers because some interesting things happen when we have negatives under our square root sign. So we're just going to assume that all of these are either 0, 1, 2, 3, 4, some positives. So I'm going to go ahead and do the first three here. So we have problem T. We have the square root of 9x squared. Well, I'm going to do the same thing here. I'm going to try to factor out perfect squares. So I'm going to deal with my number first. Well, in this case, 9 is a perfect square. So I'm going to put this little perfect square guy over here. That's nice, because that's going to factor out to be a nice number. I have nothing left over, so I'm not going to worry about that. And then I'm looking for perfect squares of my variable. Well, I know that a perfect square, like if I take a square and then I square root it, I get the variable itself. The square root of x squared is just x. Ooh, that's nice. So my x squared is actually a perfect square. So if I were to simplify that, 9 simplified square root of 9 is 3, and the square root of x squared is x. X times x is x squared. So for problem T, the square root of 9x squared is simply 3x, and I don't have any leftovers. That is actually a perfect square. That's kind of nice. Let's go ahead and do H. We have the square root of 12x squared. And again, I like treating my numbers and my variables separately, at least at the beginning. So I'm going to try to simplify the square root of 12. Well, I can break that up into, let's see, square root of 4, and my leftover over here would be square root of 3. So I try to do like, these are my perfect squares that are going to simplify nicely, and then here are my leftovers. And the square root of x squared, that is actually a perfect square, and I have nothing left over. So I'm going to simplify these. Square root of 4 is 2. Square root of x squared is x, and then what's left over is the square root of 3. So when we're writing these, we like to write, usually we like to write our numbers first and then our variable. Like I would write, I don't know, 6x. I wouldn't write x times 6. But in this case, I would like to keep my whole numbers first, and then my leftover radicals or square roots next. So I would write it like this. I wouldn't write it, I suppose you could say 2 square root of 3x, but usually we write it like that. Let's go ahead and do E. Here I have the opposite of the square root of 28x to the 4th. What would I do here? I'm going to try to factor out, I'm going to deal with my negative. I don't want to forget about that. That's pretty easy to forget about. Then I'm going to try to rewrite my square root of 28. And let's see, square root of 28, I'm going to pull out a 4. So that becomes 4. And here's another way you could do it if you don't want to separate it into your wholes and your leftovers. You could just deal with your number over here and then your variables, if you'd rather do that. This becomes square root of 4 and square root of 7. Okay, so that's dealing with my number. Now I'm going to deal with this x to the 4th. Well, what number times itself is x to the 4th? That's x squared. So technically x to the 4th is a perfect square, and I get no leftovers. So when I simplify this out, I'm going to start actually on this side because I have more room. I have a negative, don't want to forget about that negative. Square root of 4 is 2. Square root of 7 is just square root of 7. And the square root of x squared is, square root of x to the 4th is x squared. And then I'm just going to rearrange these so it looks a little bit nicer. And I'm going to say negative 2x squared. These are my whole amounts. And then my leftover is square root of 7. Poor little square root of 7. Maybe I shouldn't call it the leftover. It would feel sad. Let's go ahead and do a problem from the bottom where we might have a leftover. Let's go ahead and do E and, the 2 E's. Oh, lots of E's. This is another problem E. This is on that second row. I have the square root of a to the 3rd. I don't have any numbers here, so I'm just dealing with exponents. I'm trying to factor out a perfect square. Well, my perfect squares are actually going to be my evens. So if over here, I'll do with x's. So like the square root of x squared is x. The square root of x to the fourth is x squared. The square root of x to the sixth is x to the third. So I'm technically looking for these even values. So what's the biggest even valued exponent that I could factor out? That's going to be, I'll write this down here, that's going to be a to the second. And then what's going to be my leftover? It's going to be a to the first, because a to the second times a to the first equals a to the third. So now I can simplify this part, and this is going to be my leftover. The square root of a to the second is just a, and then my leftover part is the square root of a. I'm not going to write 1 in my exponent because we generally don't do that. So e is a times the square root of a. That would be the simplified form. Let's do the next e problem right next to it. This one actually has a number in there. 75 a squared b to the third. So I have 3 components here I want to deal with: my number, my a, and my b variable. So let's deal with the numbers first. I'm looking for a factor of 75. That's a perfect square. That's going to be 25. So I'm just going to keep my numbers and my variables together, just because I feel like doing that for this problem. So that's 25 with a remainder of 3. 25 times 3 is 75. Now I'm going to deal with my a squared. I'm going to try to factor out the perfect, or the biggest even value I can, which is just a squared. That's nice. I'm going to deal with my b's. I'm going to factor out the biggest even value that I can, and that's going to be b squared. And then my leftover amount is going to be b, because b squared times b to the first is b to the third. Now I'm going to simplify stuff. And this is going to get a little bit messy just because I didn't kind of put things in groups, but that's okay. Square root of 25 is 5. Square root of 3 is 3. Square root of a squared is a. Square root of b squared is b. And square root of b is just b. Now I'm going to go ahead and group my wholes. I'm going to put my number first, so b, or 5. And then here's a whole and here's a whole, and I'm going to put them in alphabetical order. A, B, cross them off when I use them. And now I have my leftovers. And I'm going to group those all together, and I'm going to do my number first and then my variable, 3b. So the simplified form of this is 5ab times the square root of 3b. And you might ask, why in the world do we have to do all of this work to simplify stuff? What happens is sometimes you might have this over a fractional part, and then your fractions, your wholes, can start canceling each other out, and some cool things happen there. So it is important that we know how to simplify things, because it helps later on with different problems. So that is some practice at simplifying square roots.